Here is another example that looks a lot easier than in fact it is. It's not very complicated, but it looks a little bit treacherous at the beginning. You may think that a substitution would work here. Unfortunately, because the sine is sine of 2x and the cosine is cosine of 3x, and no substitution is in fact going to work. If we try to get rid of the 2x, we're going to get stuck with the 3x and the other way around. Okay, so what is going to work here? There is an identity that is going to work, but it is an identity that probably you have not seen in high school. And no, it's not one of the usual double angle, triple angle things and so on. You may try to develop sine of 2x as double angle and cosine of 3x as triple angle, and maybe you're going to be able to do it, but it's going to be very, very long. However, there is this other identity, and it's an identity that looks like this. So it's an identity that changes the product of a sine and a cosine of two different numbers into an expression that involves actually a sum of two different sines. And of course, it's going to be a lot easier to integrate that sum than it is to integrate that product. Okay? So in this particular situation, since, oh, by the way, this formula is called the product to sum formula, or if you want to be technical and impress people, it's called the prostapheresis formula, which is a Greek, originally Greek word that means the same thing, product to sum, pretty much. By the way, there are also similar formula, product to sum, when you have the product of two sines or the product of two cosines of different numbers. Okay, so in those situations, for instance, if you have sine of 2x times sine of 3x, you may want to use the corresponding formula. I'll leave you the task to find out either from the internet or some textbooks what those other two formulas look like. But in this case, we can apply this particular formula to our particular integral. And so we're going to change our sine of 2x cosine of 3x into something a little bit different. Okay, the 1/2 is a coefficient that doesn't give us a problem. We can take it out of the integral. And then what do we have inside? Well, we have to compute, first of all, the sine of the difference between the two numbers. That gives us the difference between 2x and 3x. Of course, that is negative x. And then add the sine of the sum of those two numbers, which gives us, of course, 5x. So what we end up with is the integral of sine of negative x plus sine of 5x. Now, this is an integral, an easy integral. The first one, the first part for sine of negative x. If you're really fussy, you can use a substitution. And so for the second one, at this point, probably you should be able to figure out just by pattern recognition that that is in fact the antiderivative. So here is an example of a situation where you need to look at identities that may not be common, may not be familiar, and you may have to look them up a little bit. Again, this is another one of those situations where experience is going to count tremendously.